Hey, today I'll be talking about the project that we have done. It's baseball visualization, so we are visualizing baseball statistics over the past 100 years, and we are trying to gather some interesting correlations and see how a couple of important events in history change the game of baseball. So this is our site that we have. We start off with describing about the two leagues that we're talking about, that we're planning to visualize, which is the National League and the American League. And we also have a link to GitHub over here, so if you want to have a look at our code, please click on the link and it'll take you over there. And we have included some nice screenshots of our visualization over here. So this will tell you what to expect from the visualization tool and what you can compare and all. Alright, so let's start with the player distribution first. Yep. So we are capturing which state has produced the maximum amount of players in the past 100 years. So the state population is normalized with the number of players produced in that state, so that we give equal importance to every state. And we have applied a gradient. The darker the gradient indicates the more the number of players, and the lighter the gradient indicates that the state has produced fewer number of players. So we created a nice beautiful animation that will walk you through the visualization. So you can see that as the state color keep changing, I mean as the map has a transition in state, the timeline below keeps changing. And so if you click on any timelines, you can see green shade and red color stroking. So the green color stroking actually indicates that state has produced more number of players when compared to its previous 5 years time frame, and a red color stroking indicates that the number of players produced by the state compared to its previous 5 year time frame has reduced. So this difference we're capturing by something called heat. So if the heat is negative, the state gets a red color shading, and if the heat is positive, which means that the state has produced more number of players in this time frame when compared to the last one, stroking is going to be green in color, and the heat is positive. So if you look at this example, you can see that California has produced 16 players between 1945 to 1950, and its heat is 3 plus 3. So plus 3 indicates that when compared to 40 to 45, California has produced more number of players in this time frame. Whereas if you look at Florida, Florida has produced fewer number of players when compared to its previous 5 year time frame. So we tried adding brightness to each state instead of working with the stroking of the SVG vectors. But the issue was that the brightness was overlapping with the state color, and the effective result was something like this. So it was very hard to differentiate between California and Oregon, even though California has produced more number of players. That was causing an hindrance in our visualization, and it was not helping us achieve the purpose of the tool. So that's the reason why we went ahead and did a stroking of green to indicate that there's a positive improvement, and a stroking of red to indicate that there's negative improvement. Also, that when you click on play, you can see distortion in the map, but because every 5 years data keeps changing. So to smoothen that out, we thought of doing it for every 1 year. But then when we do it that way, we are again losing one more important characteristic, that is we are losing the heat. So since 1 year is a very short time span, the heat is not becoming a significant factor, and that was again causing some problem to us. So that is the reason why we the time frame down from 10 years to a 5 year period, so that the difference in the interpolation that you see is very little. The judges suggested us to do is if to add some social aspect to the player distribution data. So if California has produced 16 players, there must be some reason behind it. So if we can have a box over here, a shout box, or link it to a social site, so each user who visits a visualization can actually express their feelings about why do they think that California has had more number of players when compared to Florida. Um, so these are the couple of things that we're working on to make the tool more interactive. So let's look at the salary versus performance distribution. So this is one place we found out very interesting correlations. So our main aim in this was to see if a team is being paid more, does it indeed perform better? So let's look at Philadelphia Phillies. So the y-axis is marked with the salaries of the average salary of the team, and it's also marked with a rank quotient. So if there's a performance of 10, it means that the team has rank 1. If there's a performance of 9, it means that the team had a rank 2. So the lower the better the rank, the better the performance grading they get. So if you look at Philadelphia Phillies, you observe that these guys, when they were being paid more between 99 to 2000, their performance has surprisingly gone down. So these kind of statistics are very difficult to analyze if you look at MySQL data as a whole. So this visualization is actually going to help us uncover some of the important correlations that might not be obvious in the beginning. Whereas if you look at the Detroit Tigers, their performance has considerably gone up with the amount of money they get. And if you look at Pittsburgh Pirates, on the other hand, when you start paying them less, their performance has gone up. We can see that in 96 to 98 time frame. So when the salaries have gone down, the performance has gone up, and when you start paying them more, the performance has surprisingly gone down. So these are a couple of things which might be of interest to the user, because they give you some think points to think about. So we can also extend this tool by including a feature that is going to tell us the future predictions. So considering the data for the past 10 years, if I pay a team more, does it necessarily mean that they're going to perform better? And that way we've got the data for 5 teams right now. We're planning to extend this to all the teams in the Major League Baseball, and also we're trying to add a couple of new features like the prediction thing, so which can actually help the user to add in a couple of parameters and see if the salary is double, what would the performance index be. So this is a legend down here. So the red color bar indicates the performance, and the green color indicates the salaries. So the last visualization that we have is the timeline. So in the timeline, what we're doing is we're trying to capture important events in history and try to see how they have had an effect on the number of players playing in the leagues. So the top half represents the American League and the bottom half represents the National League. And we do not represent the set of all players over here because that set is huge. So instead of that, we are working on a scatter plot that can actually give you the number of players by year who have actually played in the leagues. But the main purpose of this timeline is to correlate the events in history with the number of players playing in the leagues. So if you look at the first correlation, which is the one with Jackie Robinson, so you can see that when Jackie Robinson, who was the first black player to play baseball, he did inspire a couple of few people over here. So you can see that about four players have joined baseball after the Jackie Robinson event. So it's again difficult to say if Jackie Robinson was a true source of inspiration over here. But if you look at the expansion of the American and National Leagues, this is a very important event, because once that has occurred, you see a whole lot of players joining the leagues. So probably this might be because of the free agency that had begun during the time frame, or it might be because of the amount of salary that they were getting paid. But one interesting thing that we can get into this timeline is to add a salary quotient. So if we could somehow get each year to be represented by correlated with the amount of money, the average money across all teams which each player was earning, then you can see that whether the mass increase in the number of players joining is actually because of the expansion of the leagues, or is it because of the free agency, or is it because of the amount of money they're getting paid. So one more thing that we can do over here is if for users who do not have an idea of the American League or the National League, or who do not have an idea about Jackie Robinson, We can include a hover event over here and then point them to an article in Wikipedia so that they can simultaneously read what's going on in the timeline, as well as get to know about the important events. So those are the three visualizations that we have done, and our visualization, our baseball visualization is totally built on HTML, CSS, and JavaScript and jQuery. And for server-side scripting, we have used PHP, and for database, we have used MySQL. We'd be happy to receive feedback. So my name is Vikyat, and my team is Charan, Vinay, and Ravi. We thank Dr. Watson for giving us the opportunity to work on this project. We have learned quite a lot of things, and it was great to receive valuable feedback from him at regular intervals, and that helped us stay on focus with the purpose of the project. Well, thank you. Bye bye.